Sorry about that, guys. Technology as it goes. So here we are. I think we're slightly stretched and all that, but we'll just deal with that. That's okay. So, welcome to the session, finally. Final session of this morning, continuous delivery and zero downtime. So, it's going to be a bit of a rush because we had a pretty packed program and we lost some valuable minutes. So I'm going to go a bit faster over it than I normally would, so that you can have your lunch break on time. So that's me. I've been involved in the continuous delivery space for a while as a consultant, as an independent consultant. So today I'm not going to push any particular tool or scenario there. It's more about the principles and how to achieve that. I do have some involvement in the open source community. I have my open source project for database migrations, Flyway, which we're going to talk a bit more about later. And I'm currently working on a new thing. The code name is Photon. It just allows you to take an app and package it as a VM and make it run either locally or in the cloud. But that's not the subject of today. So, as I said, we're a bit short on time, so I would ask you, if you have any questions, to please hold on to them till the end so that we can get more or less through the material, and then I'll be around during the break and we'll have plenty of time to answer them afterwards. Okay, so the goal of the session today is looking what we have to do to be able to make a fully automated deployment of a complete application. So we're going to see as well what that means and what we have to do for that into production multiple times a day with zero downtime. Now, before we do that, before we take a deep dive into that, we should take a step back and ask ourselves, this whole software development business we're involved in and what we're doing, what is it actually about, or what is the problem we're trying to solve? Well, it turns out that we're actually solving a business problem, and that's really the essence of what there. So it's a means to an end, and for that I've invited my business friend here, also called Montgomery. And how does this work? Well, Montgomery one day has an idea, but he doesn't just have an idea, he actually wants to make lots of money with it. So he goes to Ned, his favorite customer, and asks Ned, hey Ned, I've got this idea for this new feature, this new service. Would this be something you would be interested in? And Ned says, well, sure, that sounds fantastic. I would love to have that. So Montgomery goes back to his company and asks Jimbo, his Java developer, to develop the feature, and Jimbo develops the feature and tests it, and it's all working fine. So he hands it off to the operations guy. Nobody from operations in the room, I hope. And he deploys it into production so that Ned can use it. Ned can then provide valuable feedback to Montgomery, whether the feature met his expectations or not, whether everything was as planned there. So we've got a feedback cycle here, which is very important and which has improved tremendously over the last 10 to 15 years. So if we look at the different legs of this cycle, we can actually map them onto different practices in our industry. So the communication between business and development has improved tremendously, and we've really improved the speed of feedback with modern processes like Kanban, where we're very iterative, very agile for that. So that's worked really well. We've made very good progress on that area as well. The quality assurance, making sure the code we write works well once it's checked in and that everything is there. So that's really been working very well. What's still a bit at the edge in a lot of companies is actually getting this code out to the customer. So that's the focus of today's talk. That's the focus of continuous delivery. And then actually getting the feedback from the customer back to the business. That's lean startup territory, the stuff from Eric Ries, Steve Blank, Bob Dorff, and all that. But that's not really the subject for today. As I said, the focus of today is continuous delivery. So let's get started with that. I'm a bit blinded. So normally I would ask if, let's try anyway. Who's going live at least once per year on their project? All the hands? No, a couple of hands not? Okay. Once every 3 months? Yeah, it's still pretty much everyone, a couple of hands down, but once every month? It's getting thinner, yes. Every couple of weeks? Yes, we are about half, 40%. Every week? Oh, it's getting thinner now. We got 10%, 15%. Multiple times a week. A couple of hands left. Every day. Yes, one left. Multiple times a day. Sometimes. Okay, let's see. Because actually there's quite a few companies out there that you guys know that are doing that are going live multiple times a day on very big installations, and they don't have a problem with it. The first one here is the world's biggest waste of time, also known as Facebook. And they're actually quite vocal about it. They have a very nice engineering blog. They talk about that a lot. And the whole of Facebook is actually just one big binary, and that gets deployed to all the servers every single day. So they push changes there on a continuous basis, and that's no problem for them. The next one here is Flickr. They've also been quite vocal about that. They used to have a fantastic statistic on their developer page that's unfortunately gone now, but they used to have a statistic of how often Flickr had gone live in the previous week, and they were averaging about 60 to 80 deploys per week into production on Flickr at that scale. Etsy has also been blogging quite a bit about it. They're a bit smaller than Flickr, but it's still a very, very large handicraft site on the web, and they go live 30 to 40 times a day. They're very involved into that space as well, so no problem for them. But the best example that you all know is Stack Overflow. They actually publish the statistic on their website. It's hidden in the form of a version number. So if you scroll all the way down the homepage to the bottom left, there you find the version of the software currently deployed. So this is a screenshot from this morning. So let's have a look at the version that was live there. We had 2014 this year, February this month, 5 today. So they'd already gone live this morning, and the version has probably been increased already by now. So, that doesn't come out of thin air. It's something that builds on the improvements that we've done in the past. We've gotten there by eliminating some bad practices and adopting some good ones. So, what is a prerequisite to be able to achieve that? The first one is you need a solid development process. That means that this looks ridiculous, because in development we've largely moved away from that, but in a lot of organizations we still have that on the way between development and test, or test and production, where you have a large batch of code being thrown over the wall for these people then to deal with. So unfortunately it's still reasonably common. The next example here is also a solid build environment that's reliable, deterministic, is absolutely essential. And I wish this slide would be meant as a joke, but I've actually worked for a company where or consulted for a client where that was the way they were building their software. They had 70 modules, and every release meant file export jar in Eclipse. So yes, that is possible. No, we don't want that. Version control is, of course, it seems another one of these topics where, well, we've been doing that forever. Of course, everybody does that. Again, in development, maybe. But look on the other side. In operations, it's still very, very common to have lots of files being changed without any control, any history of who's done what, when, and how to deal with that. So that's still very common in a lot of organizations. And finally here, the army of testers pattern that's very spread out as well, where the business people or the test people are pushed to do monkey work day after day. That's very common as well. And it's of course something that doesn't scale. So if you start ramping up the number of releases and the number of times you push code out, it simply breaks down. So forget about that. Now, what we've described now, we're going to summarize it a bit in a small diagram to get started. So Jimbo has been developing on his local machine. He's got his development environment there. He's got all his code ready. He thinks it works, so he starts his build tool, Ant, Maven, Gradle, whatever he likes to use. And he then compiles the code and executes the tests. For the tests, I've picked up the Google terminology that they describe on their testing blog, which is a nice way to categorize your tests in 3 different types. They made it quite easy. They are the small tests that you would typically associate with unit tests. They run very fast. They're able to provide you with feedback very quickly whether things worked or not. If they did, you move over to the medium tests. You could consider this like a component test, something that would test whether your database would return the values you expected from a certain query or not. So with tools like dbunit or whatever you could use there. Run a bit slower, but do provide you valuable feedback as well. If they worked, you're ready to move on to the large tests. These are acceptance tests run with Selenium, with whatever tool of choice you like to use there. And again, they run a bit slower, but they provide you with feedback. And once that's all ready, you think, okay, to the best of my knowledge, everything is working locally. I'm ready to check in to version control. But there is no guarantee that you haven't forgotten some file or that there was some special constellation in your machine. So to make sure that's okay, we've introduced a neutral referee, which is a continuous integration server that will say, okay, something changed in version control, I'm going to double check it. So I get my copy of the latest code, and I build it, run the small, medium, and large test, and provide you feedback whether what you checked in is actually working centrally or not. So, on to deployment automation, the main part of this talk. The first rule of deployment automation is, to use a bit of Maven terminology here, do not deploy snapshots. Snapshots is the Maven term for some state in between versions, undefined, that you currently happen to have. The problem with deploying snapshots is not that the snapshot code doesn't work. You can get the snapshot code out to some server and test it, and that's all fine. But then, what do? Will you take this undefined state and put it into production? I don't think so. It's going to be very hard to be able to reproduce some issues later. So, you have to make a release. But if you make a release, you have a different artifact. Do you want to push this artifact untested into production and sacrifice your quality controls? I don't think so either. So you have to start testing again, and you haven't won anything. Now, why do snapshots traditionally get deployed? It is because the release has traditionally been associated with cost. Cost of effort, manual labor, other things that make people take a shortcut to be more efficient and deploy snapshots instead. So today, we are going to see how we can reduce the effort associated with the release to zero. So, all our tests have run successfully on the continuous integration server. We are ready for a release. And what is a release? It's actually something pretty simple. It is a way to establish a link between two entities. On the first side, we have the version control system, where we want to tag the current state of the repository as being a certain version. So in subversion terms, revision 217,300 is now called version 3.7. And then we have the binary equivalent of the version control system, which is the artifact repository, where we're going to store the output of our build process to be able to retrieve it later, so that we can then associate a certain version there, once that's running and deployed in production, back with a version of the code in version control. So, it's all nice and well, but when we actually deploy the application to make sure it is actually going to run on our target system, what do we have to deploy? What gets deployed? We have three things. First, our code, of course. We need our new functionality to be out there, the new code to execute. That's a given. But code rarely is able to behave correctly by itself in a certain environment. It usually needs the help of some configuration to know what it has to access, where it has to do that, and how things should generally be configured to work well. But that's not alone, because at some point in time we actually also want to be able to read and write some data, have access to some meaningful things. So most of the world today, and I think it's the case for you guys as well, still uses relational databases, where we have a fixed structure that needs to evolve along with the code that's accessing it. So for that, we have database delta scripts. So we have to get these strings, these three things out to have a fully functional application. Now, let's look at them each in turn. We start with the code. The code is actually something that doesn't get deployed as single class files. We don't just copy one class file here, one class file there. We usually have some kind of deployment package. A deployment package can be a WAR file, an executable jar file, an EAR file, whatever you tend to use in the Java world. So we package it all together, and then we have to get it out there. How we get it out there is a different question, and that's often answered with this. Well, I don't really know how to deploy it. The guy that normally does it isn't there, but we've got this wiki page. I think you need to copy this over, then change these permissions, create that directory, start this shell script, and then maybe we'll get it to work, but I'm not quite sure. So that, unfortunately, happens way too often. So the first step there is to say, okay, we're going to formalize this knowledge in the form of a deployment script. And already here, we start to see the first potential for synergy. If you have multiple deployment packages in your organization that are similar, that fit a similar structure, you can already start reusing a single deployment script to deal with them. And what does the deployment script do? It's the simplest thing that could possibly work to get the code out there. So it could be taking a backup of the existing version, downloading the new one, stopping the old one, starting the new one. That's it, the simplest thing that could possibly work. Now, how does that look like? We've performed our release, our artifacts are stored in the artifact repository. We now have our target system, it comes into play. And if we want to deploy something on there, we call the deployment script. The deployment script stops the existing version, pulls the new version from the artifact repository, and starts the code up. Okay, on to configuration. Configuration is a general term, and I find that there are two broad categories that fall under that. The first type of configuration is something that maybe could change someday, so we've made it configurable. And the second type is really the differences between environments. What you really have to express so that you don't access your production database when you're running a test, to make sure that these things are nice and separate, the natural differences between environments. So how do we deal with these two types of configuration? Well, if we reduce the effort to produce a release and to get new code out there, if it could change someday, maybe it could also not change at all, ever. So why carry the complexity unnecessary? I say, whatever could change someday just goes back into the code, hard code that is the new configuration in a continuous delivery world, so just put it back in there, and if it changes one day, just make a commit, it will run through the normal cycle, and it will get out there. Not a problem. For the differences between environments, I think there it's slightly different, but there is, again, a central term there, or a central question to ask, and the question is, what is the life cycle of my configuration? And it turns out that your configuration is actually pretty tightly coupled to the life cycle of your application, because your application will expect certain configuration values to be present, to be able to read them and act upon them, and the set of values might be different between the releases of your application, so you actually have a strong link there. So at that point in time, if we have a strong link between the two, why should we separate them when they really belong together? So I'm saying the configuration goes back into the deployment package as well. So we have our deployment package and we have our configuration. But we usually don't just have one environment. We have multiple environments, which means we have multiple sets of configuration. And all of a sudden, the first question arises, which one should I pick? How should I know which one to deal with? Well, it turns out, once again, the simplest thing that could possibly work, there is an easy technique to deal with this. It's called environment detection. It's a big word for the simplest algorithm to find out where you are. It could be reading the IP address, the host name, the fixed content of a certain file on disk /etc/environment, and if there is prod in there, you're in production. If there is test, you're in test. Or it could simply be a system property that you've passed to the JVM that says you are in development, you are in test. In this example here, we found out that we're in tests, so we are then able to pick the right configuration file, and the application can configure itself automatically for that environment, so that you have then one deliverable that you can take. You take the same deployment package, throw it at environment A or at environment B, and it can configure itself correctly wherever it lands. So how does it look like? The new code is started, environment detection, and auto-configuration to make sure we work correctly in that environment. But as I said, that's usually not enough. We want to deal with some data as well, so that's where the database delta scripts come into play. But they are actually something a bit special. They're a bit special because you can develop 10,000 lines of new code, and nobody will care when you push it out. But if you change 3 lines of SQL, this guy is back. Ooh, that's dangerous. You gotta be really careful here, because that could break everything. And the problem is that this is based on a very wide-based assumption in the industry that is simply wrong. And this assumption is called the fear of DDL. It's really this image here that's central, that just manipulating the data is something innocent, and DDL is really dangerous, and you got to be really careful because you could be dropping everything. But the truth is, as soon as you have the possibility to change data, you have the possibility to destroy it. So if you have an update statement and you make a mistake in the where clause, for this accounts table, this is what you can end up with. So you make a mistake, bang, you zero out your accounts, and now what's the difference from a business perspective when you look at the risk versus simply dropping the column? Either you have a very good backup or you can close shop. So the risk, as soon as you can modify data, is the same between DML and DDL. So, now let's look at our database delta scripts. Again, central question, the life cycle. The database delta is something that is tied very closely to our application, because our application, whether we're using Hibernate or whatever entities, expect certain tables to be present, expect certain columns to be there, so that they can be mapped, so data can be written and read out of it. So once again, if we have a very tight coupling between the two, why decouple the life cycle? Let's get them back together. The database delta ships in the deployment package. But immediately, if we have our database here, we have a number of questions that arise. Question number 1, in what state is my database? What objects are already present there? Which ones are missing? How do I know? How do I have to deal with that? And even if I find that out, we're not at the end of the tunnel just yet, because I might, over time, have multiple database migration scripts. In which order should I apply them? How do I know which script to run first, which script to run later? Because they have an implicit order. You cannot rename a column before you've created a table that contains it. So you have to make sure the order is maintained there. So these are problems that a lot of people had, and the first people that really came with a comprehensive solution to that were the Rails guys about 10 years ago with Rails migrations. They really provide a very good solution there. But on the JVM side of things, things were a bit lacking. So 3 or 4 years ago now, I started Flyway to fill that gap. That's the simplest possible tool you could imagine, with a very easy way in and a very easy way out. So you can take your SQL as is and let Flyway run it, so that if you're not happy anymore one day with Flyway, you're not tied to it anymore either. So Flyway allows you, if you have a number of Delta scripts, to find out first in which version your database is. So let's say it finds out your database is in version 5. You have scripts locally available all the way to version 9. So when your application boots, Flyway is able to say, okay, I'm going to migrate it to version 6, 7, 8, 9. We're good to go. We can fire up the rest of our application and get up and running. So, How does it work? The code's up and running, environment detection, auto configuration. We are able to connect to the right database, and a migration tool like Flyway will deal with it and will migrate it to the level we need for our session factory or whatever we want to use to start up. And from a technical perspective at least, nothing stands in the way for Net of using our application. There might be political issues in the way, but from a technical perspective, we've cleared all the hurdles. But we're not there yet. We still have a number of interesting problems to deal with. The first one is actually quite a common scenario. This example here, we've got Net accessing a registration component, and that registration component for our service triggers the sending of some letter that just says, hey, hello, welcome, we're happy to have you as a customer, blah, blah, blah. But someday, someone from marketing decided that paper enough is not enough. We actually want a bit more to really have delighted customers. We're going to send them a bit of candy as well to make sure they're absolutely pleased with us. But unfortunately, it doesn't fit in the envelope anymore. We now need parcels. So how do we deal with that? Well, we start refactoring, and eventually the registration component gets a new version, and we are able to send parcels, and we get rid of the old stuff. All nice and well. But what if there is an urgent bug fix that has to ship during that time? What if there is a smaller feature that's ready that should go out? How do you deal with that? The classic answer is branching, where we make a branch and we start working on that, and then eventually we have to merge it. But branching is actually comes with a number of disadvantages. The first one is, of course, you want to maintain your quality, so you have to duplicate your CI infrastructure to make sure that all the branches are tested correctly. But the bigger problem is actually that with branching, you're deferring the pain. Instead of having the pain at first, you kind of push it back and hope not to see it and hope that everything will go well once you decide to merge. And that can go well, but it gets worse and worse as the branch lives on. The potential to diverge increases, and certainly if you start refactoring things, there are simply things that your tools cannot see if they live in another branch. So it becomes increasingly complicated to get everything back together. So is there a better way to do that? Well, actually, the solution to that is remarkably simple. If we look at it this way, it's such a simple concept that it seems ridiculous. But if we have our registration component that accesses our old mail service, instead of trying to change it, we are going to do something incredible. We are not going to break it. We leave it as it is, and we simply add a logical branch that's an if statement that can direct you to the new path. Because traditionally what we really have is we have some stability island where we quickly have to release our software. Then we start refactoring, breaking things, fixing them. And then, yes, we're stable again, quick, get the release out. And off we go again. We break, fix, and let's get it out again. And so in this model here, we get away from that, and it just stays releasable all the time, but with the one twist that you don't show the features in all environments. So that you can, for example, activate a new service that's not quite ready yet in development so that you can work with it, but it's not visible in tests or in production yet. Once that's working well in development, you are able to activate it for test. If it's working well in test, you activate it in production. If it's working well in production, you can get rid of the switch so that you don't carry the complexity with you forever. Get rid of the switch, get rid of the old implementation, and you just keep the new one. And the interesting thing here is that you're not stuck to a binary mode. You can start playing with all kinds of things where, for example, you get some features out into production, but only for a certain set of users. Maybe for internal employees only, and not for the general public so that they can get a taste of that on the real infrastructure and see how it performs on the real infrastructure. Or you get a certain percentage of your users using that, and if that works well, you increase it and you gradually increase it more until eventually everybody's using it. So there's lots of potential to achieve other outcomes that you couldn't achieve with traditional branching. Now, with that, you're able to release at any time, but you're still not able to release without downtime, because there are still some little things biting you. Traditional diagram here of the architecture of most organizations, where you've got the client, and then you get in, you've got some kind of load balancer that's sending traffic to some application server, and that actually needs to access some database to be able to get some data out there and process it and send it back to you. Now, all nice and well, until a new version of the software appears. So the first step here is to deploy it next to the existing system, so that you don't take the existing system down, you keep on serving requests. We've seen what happens when the software starts. Environment detection, auto-configuration, we access the database. It could even be that it ships with new migrations, and we migrate the database. So here, it's very important, we're going to have a look at an example in a minute, that once you start changing the database, that you stay compatible with all versions of the code that are currently live. So hopefully, there is a maximum of 2 versions, but it could be more. But you have to stay backwards compatible so that in case something goes wrong, you can simply shut this guy off and you keep on serving requests over there as if nothing happened, so that you take off the time pressure to fix the things. Now, once that's working well, you can start releasing traffic onto the new instance. But there is still one problem left: state. If you have state on the middle tier, typically your sessions, could be different types of caches as well, you are in a bit of trouble if you're not careful here, because if your user had a session here and he's now coming here, that data is not going to be there. So how do you make it accessible? How do you deal with that? The traditional answer to this has been session stickiness, so that once you have a user that's attached to a certain server, it's always going to be that server that's going to be serving the request for that user. But you don't even have to be in a 24/7 business for these sessions to take a very long time to drain. If you're in Sweden, somebody gets up in the morning at 8, logs onto their machine, works the whole day, takes a lunch break, goes home. It could be 8, 9, 10 hours until that session is finally eligible for collection. So that's really too slow for what we want to achieve here. So the trick is to get rid of the state on the middle tier and either go to the front or to the back. So to the back, that could be storing the sessions in a database or in an in-memory cache or what you use there. Or going to the front could be storing the sessions in a cookie, which is the default for a lot of frameworks outside of the Java world. The Rails guys have been doing that forever. Now it's slowly entering the Java space as well. Play is doing it in the cookie. And it actually turns out that it's working reasonably well, because you can make it secure, you can encrypt it, and you can sign it so that you know that it's not been tampered with. And you've got a limit of 4K, but generally it's a pretty good practice not to exceed that anyway in the session, so that that works with that. But it also has implications on the memory requirements of your system, because otherwise you need to provision the memory here for all the sessions of all that are currently active. And in this scenario here, if you move it to the front, you only have to provision enough memory for the sessions that are actually executing, and that can be a big difference as well. So, eventually, once you're through there and everything has gone well, you can then decommission the old version and switch to the new one. And the next one after that will come up here, and they call it blue-green deployment, because you switch between the blue and the green, and back to the blue, and back to the green. So you can switch back and forth like that as the versions roll out. Now, how does it work with a database? A quick example about renaming a column and how you would traditionally do it and what you should do in a world with zero downtime to be able to deal with that. So very simple table here, first name, last name, and we have old code out there that's actually accessing it through surname. That's the name of the column. We're not quite happy about that. We'd like to rename it to last name. How to deal with that? We've got the existing code. But now we have a new release. As I said, it wants to access it with last name instead of surname. So how do we deal with old and new coexisting? The old solution of simply doing an alter table and renaming the column doesn't work anymore, because then either one or the other would break. So we can forget about that. Instead, what we have to do is add a new column so that we have both old and new. We then create a trigger for any new data to come in and copy it over as it comes into the other column, and we then bulk copy all the existing data at once with an update statement so that we're able to serve both versions at the same time. Once the old version has been decommissioned, we are then able to ship another version as a follow-up that will be able to clean up all this transition and all this old stuff. So what does it do? It gets rid of the trigger again, and it will drop the old column so that we're left with only the new world. So that's really the three phases you always have to deal with. It's, if you go from A to B, you go from A to A plus B to B. And with that, you can have a very smooth transition along the way. A lot of these things are actually explained in the steps you need to take to achieve that are explained in a book called Refactoring Databases, and that's quite good because you don't have to reinvent the wheel. You can just use whatever recipes are described there, and they'll work. So let's bring it all back together and map all these concepts on specific technologies you might be using. So Jimbo has been developing in Eclipse or IntelliJ. He executes a local Maven Ant or Gradle build, triggers the JUnit tests, DBUnit tests, and Selenium tests. He then checks in Subversion, Mercurial, or Git. Jenkins or Bamboo will check that something changed there and executes the Maven Ant or Gradle build with JUnit, DBUnit, and Selenium tests, and we perform a release so that we can tag Subversion, Mercurial, or Git and upload the artifacts in Artifactory or Nexus. We are then able to trigger our deployment script that will pull the new artifacts from Artifactory or Nexus. We'll stop the old version, start the new version. Through environment detection, we find out where we are so that we can configure ourselves automatically, and then we can invoke a migration tool like Flyway to get our database up to speed so that there is nothing left in the way for Ned to use our software. So all the pieces of the puzzle described here have been available for a very long time. You simply have to put them together. So once again, one deployment package with code, configuration, and database delta, with environment detection and auto-configuration, with a database migration tool to get it up to the level you need so that you can then use feature toggles to release at any time. But never forget, if you have to deal with state, be very careful because it could be out there to bite you. What I've talked about today is covered in part in this book. We don't have a perfect overlap of our material, but there is lots of very, very good ideas in there. So I certainly recommend you to have a look at that. It has a lot of depth. It's very good. But I think one of the most important aspects is one we haven't talked about yet. Once you've gone through all this, once you've executed on all that and implemented it and gotten to the point where every commit really triggers a release and deploys it, it will change your mind and the way you approach things. It demands slightly more discipline. You need to think a bit more in advance about what will happen. But what you get from it is reliability, is being able to take away the time pressure if something goes wrong, and all kinds of new ways of thinking. So we've already talked about hard-coded is the new configuration. But you also have the option now, if you've got these very short release cycles, to say, if something goes wrong, depending on the severity, if it's not that bad, maybe I can roll forward instead of rolling back. Maybe I can just fix it and let the normal pipeline deploy everything and get it out there instead of having to interrupt everything and take a step back. So that's all I had for today. Thank you for your time.